Going to discuss about rotational axis of symmetry can be represented with Cn and it can be generated by rotation operation, right? So here I am taking the water molecule as example where H2O is the molecular formula, right? Oxygen and two hydrogens. By doing 180 degrees rotation, as I said, if I rotate 90 degrees like this, again by rotating 90 degrees, that means totally 180 degrees, we getting the equivalent structure to the original one, HA, HB. By rotating 180 degrees, HB will come here, HA will come here. Again by rotating 180 degrees, HA will come here, HB will come here, right? So here 180 degrees rotation we getting 1, 2 are equivalent configurations, and whereas 1 and 3 are said to be identical configuration, which are same in molecular formula, same in position of atoms. Okay, and this rotational axis of symmetry can defined as 360 by theta, where n is order of rotation and theta is angle of rotation. If theta is 180 degrees rotation, 180 degrees angle, Cn will be 360 by 180, right? So Cn will results C2, two-fold rotational axis of symmetry. If theta is 120, Cn will be 360 by 120, it results C3. If theta is 90 degrees, Cn will be C4. If theta is 72, Cn will be C5. If theta is 60, Cn will be C6. So in linear molecules, generally theta is 180. So angle of rotation is C2. In trigonal planar, theta is 120 and it is C3. In square planar, it is C4. In pentagon, it is C5. In hexagon, it is C6. Here I am taking the BX3 as example, where BX3 is having trigonal planar structure like this. B and 3 halogens are here. So angle between the two atoms is 120 degrees. So by doing 120 degrees, we will get the equivalent structures like this. Okay. If it is BX3, boron and 3 halogens are here. So the angle between these two atoms is 120 degrees. If I rotate the molecule like this. So here I am putting the axis through the boron. Okay, so I am rotating the molecule like this. Okay, so by rotating 120 degrees, we will getting the equivalent structure. So here the rotation must be in one way, in clockwise manner or otherwise in anti-clockwise manner. Okay, so the rotation would be like this. So the axis, I am putting the axis like this. Okay, so by doing 120 degrees rotation, we getting the equivalent structure to the original one. Okay, so additionally from B in BX3, additionally BX3, additionally C3, again C2 also possible. So if we pass the axis through one of the halogen and boron like this, so if I put the axis like this, so the axis is passing X1 and boron. These two atoms will be replaced to each other. X2 will come here, X3 will come here, right? So this is generation of one C2 axis. So like that, 3 halogens are here. So 3 C2s will possible. In these cases, the highest fold rotational axis, that is in BX3, C3 is called as principal axis of symmetry and 3 C2s will called as secondary axis of symmetry. So if you see in square planar structures, so the angle between two atoms is 90 degrees, so that the principal axis is C4 and 4 C2s will called as secondary axis. So if you see in a pentagon, so the axis between the angle between the two atoms is 72 degrees, so that the principal axis is C5 and 5 C2s will consider as secondary axis. So same like that in hexagon, the angle is 60 degrees, so that the order of the rotation is 6. So it is C6. So C6 will be the principal axis and the 6 C2s will consider as secondary axis of symmetry. We take ethylene as the example. So whereas the ethylene formula is C2H4, 2 hydrogens were placed like this and 2 carbons will placed like this and 4 hydrogens will placed like this. If we see the model, the 2 carbons will having the double bond in between them, and 4 hydrogens will be like this. Okay, so the one of the C2 is passing through 2 carbon atoms like this. It is C2. Again, one of the C2 axis will be placed like this in between the pi bond, and it is one C2, and one of the C2 is possible through the center of gravity. Okay, if you see in the model, the axis is like this. Okay, this is one C2, and if I put the axis like this, it is one C2. So in between the center of gravity, that means 90 and 180, right? So like this, 3 C2s will possible. Here the order of the rotation is same, right? So in these cases, the C2 which is passing through more number of atoms, that means this C2, right? So it is passing through more number of the two carbon atoms, right? So it is called as principal axis, and the remaining C2s will called as secondary axis.